4 minus 4.5. What is the value here? It is 3, 5. 3 minus 5. 3 minus 5. And it will give me minus 0.5 and minus 2. Okay, similarly, I will calculate x4, x5, x6 here. Okay, so what will be the vectors here? I will write in next page. So the vectors I have here is, first is minus 2.5 and minus 4. Okay, second vector I have here is minus 1.5 and 0. Third vector I have minus 0.5 and minus 2. Fourth vector I have here 0.5 and 1. Okay, and another vector I have 1.5 and 2. And another vector I have 2.5 and 3. 2.5, okay, it is like I have this is 2.5. Okay, so this is the calculation we have done here for each vector. Now I will calculate the covariance matrix. Covariance matrix, I will do the calculation. So now nothing is there, already the subtraction you have done, and the covariance matrix is the formula I will write here. So this is x1 minus mu. For first vector you are x1 minus mu transpose. Okay, so here it will give you x1 minus mu. Already you have the vector minus 2.5 minus m2. Also x2 minus mu transpose. So x2 is here minus 1.50. Okay, and here it is minus 1.5 and 0. So it will give you the value like this: 2.25, 0, 0 and 0. Okay, next M3. I will calculate here this is minus here. So I will take here minus 0.5 and minus 2. And here I will write again this one minus 0.5 minus 2. And it will give us 0.25 114. Okay, similarly I will calculate M4 here. So M4 is, that's 1.52, and here it is 1.5 and 2, and it will give you 2.25, 3, 3 and 4. Similarly, M6, you will calculate 2.5, 3 and 2.5 and 3, and it will give you 6.6, 6.25, 7.5 and 7.5 and 9. So this is like the covariance matrix we are getting here. Okay, and in covariance actually we need to divide by n also, so that we have done here. So what you can do in next, you can do it m1 plus m2 plus m3 plus m4 plus m5 plus m6 and divide this entire by 6. Okay, So the covariance matrix will be like this: 1 divided by 6, and you are adding all these values, so it will give you 17.5, 22, and 22 and 34. So the final covariance matrix, you will got it here: 2.92 and 3.67, 3.67 and 5.67. Okay. So if you know the property of covariance matrix, the values will be same here. Okay. So this is like we have calculated the covariance matrix. Now I will calculate the lambda here. So that is like is an eigenvalue for a matrix M here. So lambda is an eigenvalue for a matrix M. For a matrix M. So with this, actually the formula here is M minus lambda of I is equal to 0. Okay, so for this I will calculate 2.92, 3.67, 3.67 and 5.67. So this is my matrix here, and I will write here lambda identity matrix is like this one is equal to 0. So we need to do this calculation in matrix form. So in first time you will go to 2.92 lambda, 3.67 and then 3.67 and 5.67 lambda is equal to 0. Okay, so I think you can solve this equation. We can solve this equation like 2.92 minus lambda, okay, 5.67 minus lambda and minus 3.67 into 3.67 is equal to 0. So when you will do the calculation here, it will give you 16.56 minus 2.92 lambda minus 5.67 lambda plus lambda square minus 13.47 is equal to 0, and the final equation will be like this: lambda square minus 8.59 lambda plus 3.09 is equal to 0. And this equation you can solve, and you will solve it. It will give two values of lambda because the quadratic equation. Lambda will be 8.22 and 0.38. And which value you will consider from here? So for that purpose we have studied PC actually. So you will take the maximum value from here. So you will choose 8.22. This value you need to discard. You can't take 0.38. So it is 0.38, and already we have discussed in PCA that you can't take that value. So we find the eigenvector corresponding to this lambda 1. Okay, lambda 1 and lambda 2 we have here. So we have, in simple mathematics, we know very well mx is equal to lambda of x. Okay, so we will take M is a covariance matrix here. Covariance matrix. Okay, and x you will take the eigenvector here. You will calculate eigenvector. Lambda already you know 8.22. So here the everything is known 2.92, 3.67, okay, 3.67 and 5.67. So this is the matrix I have here, okay, and then I will calculate this x1 and x2, and this is my value of eigenvalue is there, and this is x1 and x2. So from here you can calculate, you have the equations, you will form the equation from here. First equation will be 2.92 x1 and plus 3.67 x2 and is equal to 8.22 x1. Okay. Second equation will be 3.67 x1 plus 5.67 x2 is equal to 8.22 x2. Okay, so when you will simplify it, so you can simplify it very easily. This portion will be this side, it will give you x1. Okay, and this portion will be this side, it will give you value of x2. So finally, you will get it 5.3 x1 is equal to 3.67 x2. And another is 3.67 x1 is equal to 2.55 x2. Okay, for solving these equations also we use linear algebra actually. So, okay, from here you will got like x1 is equal to 0.69 x2 and it will give you x1 and x2. This is the eigenvector here. Okay, you can write here eigenvector is equal to 2.55 and 3.67. So I find out the eigenvector. Okay, so this is the principal component for the given data set. This is the principal component for the given data set we have calculated. Principal component. What you can do, you can check the what will be the value, okay, when you will project on the line actually on the line. So use PCA to transform. I will transform the 2 1, only one. So the first vector I have is 2 1 with me. Okay, I think you remember on to eigenvector. So the feature vector 2 1 will transform like this. Transform. How it will transform? So it will be like transpose of eigenvector. I'm writing the formula here. Transpose of eigenvector into feature vector minus mean vector. So like that it will form. So let me check what will be the value here. So transpose of eigenvector will be 2.55 and 3.67. Okay, and the value here feature vector minus mean vector already we have calculated for 2 1, if you remember it. Okay, so this is the vector and it will give you this single value, that is minus 21.055. So you can check here, we have transformed this into a one-dimensional vector. So this is the total we have told, I told, we have discussed in principal component analysis. So if you will choose more values for eigenvalue, then it may be 2D. Okay, suppose you have 100D, you can convert into 2D, 1D, 3D, like that. Yes, any doubt? If you have, you can ask me. Okay, if you are not asking, then I will discuss the Python coding here for PCA actually. So this is for PCA. So I have here import matplotlib.pyplot as PLT, numpy, pandas, and I am using here sklearn.dataset. So the dataset I am taking here, that is load breast cancer. So I have uploaded this dataset here, and I am taking directly from sklearn. Okay, so I will compile this portion. So this is the detail for my data set here. Breast cancer data set I am taking. This is a characteristic. Number of instances are 569. Number of attributes are 30. Okay, numeric predictive attributes in the class. So radius. These are the information of data. Texture is there, area is there, smoothness, compactness. So okay, and this is the details of data. Minimum value is this one, maximum is this one. Texture, this is the minimum, this is the maximum. So all the data is given here. Okay. Missing attributes, nothing is there in the matrix form. So we have done this calculation. So nothing is there. Now I will take this data through data frame. Okay, so data and column, I have given the feature name and everything I have printed here. So when I am printing head, so it means it will give you 5 rows. In starting 5 rows it will give. Okay, so total data is there. So this is the data set I am using here. So now I will fit the data. So this is my data scalar dot transform into df. Copy is equal to true and scalar dot fit, and this is the scaled data here. Okay. Now I will runtime disconnected. Wait for a minute. So here I am taking the PCA from this one, this library sklearn dot decomposition import PCA. So this is the PCA here. So PCA is equal to PCA and components is equal to 1. So here I want to convert the data set into one dimensional. Okay. So remaining is this transform and shape of the data it will give you, and I will compile this and you can check. This is 569 into 1. So already when we are checking this data, the data is here. So it was like 569 and 30. But here it has converted into one dimensional data. One dimensional data. Okay, the original data again I am writing here 569, 30. So if suppose you will take more values of eigenvalues, suppose I will take 3 values eigenvalue, then it will convert into 3 dimensional. So you can check here, it is giving 569 and 3. Okay, so it depends on the application, in which application you are using it. And here you can check this first principal component and second principal component. We have done is in this figure. Okay, so this is available in this particular library. We are using actually when we are doing coding for machine learning, always we are using this also. So one more thing I have, yes, these are the PPTs we have for this one, because teaching from PPT directly is like very boring sometimes, so I didn't use. But everything is there, so I will try to provide you in future. So if you have any doubt, you can ask me now. You can write in chat box if you have any doubt. So the next lecture will be taken by Matthew Srinivas. He is assistant professor in NIT Bharat. So the next lecture will be taken by Matthew Srinivas. He is assistant professor in NIT Bharat. So you can go, but don't like sign out from this meeting, please. Okay then. Thank you very much. If still you have doubt, you can ask me. Otherwise,
Okay, thank you, sir.
okay. Thank you very much for your cooperation. You have listened.
Thank you, sir.
Good evening, everyone. Am I audible to everyone?
Yes, you are audible.
Okay. Today's uh, today's session will be delivered by Professor Mittu Srinivasan. It is it is both privileged and honor to introduce Dr. Mittu Srinivasan.
Wait, Anchal. He's not there, I think.
Okay.
Wait, I will tell you.
Am I audible to everyone?
Yes, you are audible.
Okay, sir. Good evening, everyone. This session will be delivered by Professor Mitu Srinivas. It is both an honor and a privilege to introduce Dr. Mitu Srinivas, Assistant Professor in the Department of Computer Science and Engineering at NIT Warangal. Dr. Srinivas completed his PhD from the Department of Computer Science and Engineering, Indian Institute of Technology, Hyderabad, IITH. He brings a wealth of academic and research experience, having previously worked as a postdoctoral researcher at the Department of Computer Science, Canada, and at the Institute of Information Science, IIS Academia Sinica, Taiwan. His research interests span across cutting edge areas like computer vision, deep learning, machine learning, medical imaging, and sparse representation. Beyond, beyond his research, Dr. Srinivas is a passionate educator, having organized numerous FDPs and workshops focused on machine learning, deep learning, and data science. Today, we are fortunate to gain from his rich academic and practical insights. Please join me in welcoming Dr. Mitu Srinivas. Now, I would like to invite Dr. Mitu Srinivas to continue further. Thank you.
Yeah, thank you. Thank you, Sushil sir. First of all, good afternoon to all the participants. So, in this session, I want to discuss about the some basic related machine learning, and if the time permits, I will go with the unsupervised learning methods. Yeah. So, my screen is visible.
Yes, sir. It's visible.
Yeah, thank you. So basically, I think this is the introduction about the machine learning. So previously, one of the sessions started the introduction about the data science and the corresponding regression models, and then after that you can start with the decision trees kind of thing. So here I want to give the more clarity on why the many terminologies came and what are the difference between the one terminology to another terminology. Then after that, what are the feature representations is there, and then the image related and other type of the feature representation. Then after that, we will discuss about the unsupervised learning method. So basically, current days we are listening the many words related to the artificial intelligence, machine learning, deep learning. Other than these terminologies, some other terminologies like data science, soft computing, or NLP, text mining, computer vision, signal processing. So like this, so many terminologies is listening nowadays. So why these many terminologies came, and what is the relationship between these terminologies? Any relationship is there, and what is the what is contained inside? So first of all, we are discussing about the artificial intelligence. So what is mean by artificial intelligence? So artificial intelligence is nothing but the simulation of the human intelligence into the machines. That machines we can call as a AI. So in that case, that machine like act like a human, work like a human, think like a human. Only that type of the machines only we can call as a AI. So suppose if I say the AI means everyone think about the robo kind of thing. So basically two different type of the robots is there. So one type of the robot, you can see the many big manufacturing companies like car manufacturing company or maybe computer manufacturing company. So in that manufacturing companies, many stages is there to develop the product. So each and every stage humans are not involved. So machines is there, the machines will be involved. For example, you can consider the car manufacturing company. So in that case, for different stages is there. One stage they will do the assembling the body parts of the car. Another stage they do the welding. Another stage they do the coloring. So like this, many stages is there. So you can see the, for example, you want to assemble the car body parts. One body of the car is coming on a track, and one robo is there. So the robot have some car window is there, then it will go to the particular position and it will fix the car window to the car body. So like that it will fixing the robot. Suppose the robot, in that case, it is like act like a human, work like a human. It is not think like a human. So why I'm saying it is not think like a human? Suppose you can rotate the car body some particular angle kind of thing. So this try to fix the car door. So the car door also not rotated in particular angle. Exactly what the previous angle is the same. Try to fix it. So in that case, it is not thinking like a human. This type of the robots are we not called as a AI. Another type of the robots is there that we can call as AI. Simply, for example, everyone knows one Sophia robot is there. Okay. Suppose if you go and approach the Sophia robot, if you ask some question, the question related to how are you kind of question you are asking, then what the robot will give the response to you, how the humans will be respond the same way, that type of the response is given to you. For example, it is fine, okay, I'm good, I'm fine, like that. If it is not, then it will say it is not good. Okay, so it is not give the irrelevant response, it is give the relevant response how the humans will be respond. So that type of the robots we can call as the AI. So AI kinds of many things is there, maybe logic based kind of thing, search based kind of thing. So once we are talking about the learning based kind of methods. Okay, so the learning based methods we can call as the machine learning. So what is mean by machine learning? So machine learning is the one of the application of the AI. So what is mean by machine learning? Machine learning is the one of the application of the artificial intelligence. So in that, it will be provide the system the ability to learn automatically and improve from the experience. Experience is nothing but the past information. Without being explicitly, we are providing any extra information. Without we are providing any extra information means we are not providing any feature related information. So based on the past information only, it is automatically learn and it will do the prediction. So that we can call as the machine learning. So for example, nowadays we can see the weather forecasting kind of thing or stock market prediction kind of thing. Like this, many things are we are doing the prediction. So in that case, what will happen? The based on the past information. For example, they want to do the weather forecasting kind of thing. So past information means how the yesterday or today or maybe day before yesterday, how the humidity is there, how the wind speed is there, how the rains is there. Like this, it will collect some attributes. So based on that, what is going on in the coming days means what is happening in the tomorrow, any rains will come or not, what type of the rains will come, any heavy rains come or normal rains will come. So like that, we can do the prediction. For example, another case you can consider, you can go to the 4 years back, like 2020. So in that early stages of COVID, so many people they use this machine learning techniques apply on that. How the COVID spread rate is there, how the COVID death rate is there. They accurately predicted at the time of May or April time kind of thing. So that much of accurate results we can predict based on the past information without explicitly we are providing any extra new information. So that is nothing but the machine learning. So machine learning basically two type of learning methods is there. So one we can call as the supervised learning algorithm. Another one you can call as the unsupervised learning algorithm. And one more we can call as the reinforcement learning algorithm. Okay. So here mainly I will concentrate on the supervised and unsupervised learning algorithms only. Okay. So suppose if we ask the question, so what is the difference between the supervised and unsupervised learning algorithm? Any response? I am audible?
Yes.
Yeah. So suppose if I ask this question to many of the person, they will say the simple answer is if it is supervised means it is contain the labeled data. If the unsupervised means it is contain the unlabeled data. Okay. So this is correct answer, but I need to go more in depth what is going on internally kind of thing, internal operation, how it is working supervised, how it working unsupervised. So, okay. So at this stage you can think only remember it. Supervised means it is contain the labeled data, unsupervised means contain the unlabeled data. So each category it consists of many different type of techniques or methods. For example, if you go to the unsupervised learning methods that we can call as the partition based clustering algorithms and hierarchy based clustering algorithm and read based clustering algorithm and density based clustering algorithm and model based clustering algorithm. So like this different type of category of unsupervised learning methods is there. So unsupervised learning methods we can call as a clustering. Next, come to the supervised learning algorithms. So supervised learning algorithms we can call as the classification problem. So in this also different type of the classification methods is there. So what are the classification methods? You already maybe one of the classification method already you seen in the second day itself. So that is a decision tree based classification method. Okay, so another type of the classification method is the naive Bayesian classification method and neural network based classification method, and one more is the support vector machine classification method. So here we are talking about the neural network based classification method means how the human biological neurons are working. The same way they build the one of the classification method is called the artificial neural network. They will call the simple form ANN. Okay, so ANN is nothing but artificial neural network. So how the human biological neurons are working, how the human biological neurons are connected. So the same way they build the artificial neural network. So if you know already a little bit idea about artificial neural network, just the artificial neural network is consists of a multiple layers is there, like input layers, hidden layers, and output layers is there. Okay, so each input layer we can give the input to the corresponding hidden layers, and hidden layers you can do some kind of computation, and once what you are getting the output of the hidden layer, again that is input to the next hidden layers like that, and finally how the output layers is there. So like that you have the connections is there between the your input nodes and hidden nodes to the output nodes. Okay, so here in this also you can learn more detail about this neural network concept. Just you can think about like this architecture is there. Okay, so before this architecture, if you are here hidden layers, how many hidden layers you are taking, then we can call as that is the deep network kind of thing. If you have the more number of hidden layers is there, then that architecture look like it is a more deep kind of thing. So that's the people call as a deep neural network. Okay, so before this input layer, here we are adding the some more extra layers. We are adding the some more extra layers. So this extra layers we can combine with the artificial neural network, so that we can call as a deep learning. So deep learning is the just extension part of the artificial neural network only. So deep learning is the not the new kind of thing. Just before artificial neural network, what are the layers contained? Before that, you add some more extra layers. So this is just extension of the artificial neural network. Artificial neural network is the one of the supervised learning algorithm. Supervised learning algorithm is the one of the machine learning technique. Machine learning is the one of the application of the AI. So these all are comes under the AI only. Okay, so this is the relationship between the AI, machine learning, and deep learning. Now come to the other case. Maybe what I'm saying, other terminologies is there like data science and NLP and text mining and medical imaging and computer vision and signal processing. Like this, many techniques, many terminologies is there. So what is the difference between these terminologies? Why this many terminologies came? So based on the what type of the data you are using, or based on the what type of the methods you are applying. Okay, so based on the what type of the data you are using, and based on the what type of the methods you are applying. So based on the methods means, for example, you can consider the data science. So what is there in the data science? For example, in the initial stage, like data acquisition and data pre-processing and data maintenance, and you perform operations on that one. Then finally, you can get the data visualization. So here, everything we can deal with the data. Most of the people, they use the statistical based methods to perform all this type of the stages. So already you've seen some of the statistical based methods which are available in the machine learning is called the regression models. In the first day itself, you can have the session. Okay, so with the help of this regression models, we can find out the predict the some kind of the condensed data, what is the prediction we are doing. Okay, based on the methods they given the terminologies and based on the data. So nowadays a very different type of the different formats of the data is available. For example, here how the one textbook is there. Okay, so normally textbook is consists of a what, the one cover page is there, that is called the front page. Okay, so this front page, what is contained? It is contained the title of the book, author names, publisher name, and year of publication. So like this type of the information is available in the Cover page. Cover page means front page. So this information, the title of the book, author name, publisher name, year of publication, is not available inside the pages. So it is available only outside the book only, means cover page only. Suppose I remove this cover page. Okay, I remove this cover page. Then I given that this textbook to you. Okay, so after I given this textbook to you, I told you can read the textbook and you can inform to me once your reading is completed. Then you taken the some time, 10 to 15 days. So after 15 days, you approach to me. You told, okay, my reading is completed. Okay. Now I am asking the question, can you recognize the book is related to which subject? So the identification is possible or not? Any answer? So after reading the book, can you recognize the book is related to which subject? It is possible or not? So it is not have any cover page or front page. It's contain the only content is there. So based on the content, we can easily recognize the book is related to which subject. How you recognize? Based on the content means here the textbook. Textbook is contain the what? It contain the paragraph. Paragraph contains the what? A sentence. A sentence contains the words. So based on the words, we can decide the book is related to a particular subject. So based on the words means you can use the all the words. No, we are selecting the some specific words. That words we can call as the keywords or special words. So based on these keywords or special words, we can easily recognize the book is related to the particular subject. For example, after reading the book, you identify the some words like this. The words are entity, relationship, primary key, foreign key, normalization, transaction management. Like these words you identified. Can you tell me the subject is related to the which one? Or the book is related to which subject? So where you see the attributes, entity, relationships, and it's a primary key or foreign key kind of thing, or where you can see the transaction management kind of things. So that mostly we can identify in the database related. So if this book is related to that, we can say it is the database related kind of the subject. Suppose another example you can consider. So after reading the book, you identify the words like this. The words are semaphore, smartest, critical section, kernels, scheduling, jobs, like this kind of words you identified. Then can you tell me the book is related with subject? Operating system. So here you are not consider the all the words. You are selecting the some special words that we can call as the keywords. So mostly 6 to 7 words is given both the cases. So based on that only we can easily recognize, okay, this book is related to the particular subject. So in this case, this is the document case. You can use the words we can call as the special words or keywords. Okay. Suppose this FDP is going on physically, then I came to your college, then your coordinator is introducing about me is Dr. Srinivas from NIT Warangal. Then when you are seeing on first time, so what is going on in your brain? So you can see the how the my face is there, how the my skin color is there, how the my height, and what is the my height, what is the my personality, what is the my gesture, and what is the my dressing style, and what is the my hairstyle. So how the my nose is there, how the my eyes is there. This all information will be extracted, so that will be stored into the your brain. Okay, so not only your brain, all humans, the same kind of activity is going on. Suppose in another example, you meet the some new persons, then after some discussion is completed, then you want to take his or a phone number, then what you'll do? Just first you want to open your mobile contacts, first you enter the phone number, then after that you enter the name of that person. Suppose with that name in your contacts already someone is existed. Okay, then what you will do? So for example, already in your contact Srinivas is there. Now again you want to say that with the Srinivas, that is not possible. So what you will do, you can add the with the Srinivas, you can add the either place name or surname kind of thing. Then we can easily discriminate the already which are the contacts with have the same name and current one. We can easily discriminate with this extra term. Okay. So here the Srinivas NITW we can call as a class name, tag name, or label. All are same only. Okay. So like the class name, tag name or label, we can call as a then what you have saved the name. Okay. So like that you have saved the name on the your brain. Suppose suppose this workshop is completed, then after that 15-20 days is over, then again I came to your college. Maybe I will be there in the another seminar hall or maybe somewhere in your college canteen. Can you tell me when you seeing on me second time, can you recognize me or not? So definitely we can recognize. How you are recognizing? The same way how the information stored in your brain, the same type of the information will be extracted again, like height, personality, skin color, hairstyle, or maybe dressing style, or maybe eyes, nose, and skin color. This all type of the information extracted, and within the fraction of second, it will be matched with the already stored information in your brain. So we can easily recognize who is that person. So that is regularly going on activity to recognize the persons or humans kind of thing. Otherwise, can you see on top of my face, my biodata, any biodata is there in the words like screen was like that, anything is written on my face? No, because I am not the document. I am not have the words. I am the human, means human related information or human related properties only is there. So human related physical properties, what like height, personality, gesture, skin color, or this type of the human related properties. So based on that, we can easily recognize, okay, he is the human of this person, like that we can recognize it. So this is another type of the data. For example, we are listening to some kind of music related kind of information daily. Okay. As I am speaking something so that you record it in audio kind of thing, then how that information is stored in case of audio, it's stored in the form of the signal. Suppose if I give in the signal, then I ask the question, what is this signal? This signal is the speech related signal or music related signal. If it is speech related signal, who is the speaker, X or Y? If it is a music related signal, what type of the music, like pop music, rock music, classical music, or different type of the music is there. So like that, I given this input signal, then I ask the question, the signal is related to the what? Is a music related signal or speech related signal? If the music related signal, who is the speaker? If it is a speech related, who is the speaker? It is a music related, what type of the music? So can you see on the top of this signal any information is available? Okay, this is the person, this is the type of the music, like that any information is available? No, because it is the related to signal. Signal contain the what type of the information? The signal contain the frequency related information only. So based on this frequency, you can recognize that is a speech related signal or music related signal. So it is a frequency related information. So that related properties only you can extract. That properties we can call as the MFCC features, well frequency spectral coefficients. So it's maybe 39 values or something is there. So based on that values, we can easily recognize that signal is related to the music related signal or speech related signal, or who is the speaker or what type of the music. So based on these properties or these features only, we can easily recognize. So here clearly observe it. So based on what type of the data you are using or methods using, they given the terminologies. Okay. For example, it is the text document, then they given the text mining kind of thing. For example, I am using the medical image related data for classification of the finding the abnormality or normality kind of thing. So in that case, for classification, I use the supervised learning algorithms. Different type of supervised learning algorithms is there, like ANN and what are it, maybe support vector machine classifier, apply on that. Then I can detect, means I classify it's a normal or abnormal kind of thing. So when you are working on that medical data, they will call the medical image. Suppose I want to detect the object or classify the objects based on the CCTV footage video kind of thing, that is a video data. So that video data also based on the actions, human actions, I need to classify that is the normal or abnormal activity or kind of thing. So in that case, again, the same computer vision means in that computer vision related properties will be extracted. Based on that, we can classify that is the normal or abnormal using any one of the supervised learning algorithm. So they given the terminology is called the computer vision. So here, what type of the data or what type of the methods they're using, based on that, they're given the terminologies. Okay, so that's the reason that the terminologies came here, the different ways, NLP, text mining, medical imaging, computer vision, signal processing, like that. So mostly again they use the machine learning techniques for classification or recognition kind of applications. Okay, so here I want to give the more clarity on what is the feature, what is the feature representation. So if you are using the machine learning kind of the methods, or when you're applying the machine learning kind of applications on your data, so almost 60 to 70% of the your accuracy is depending on the what type of the features you are using, or what type of the feature properties are using. Okay, and what type of the attributes you are using. So all are same only, features, properties, attributes, all are same only, same terminology. So almost 60 to 70% of the your accuracy depending on the your feature representations only. Suppose your features are not good, okay, your features are not good, even though you are using the best methods in the supervised or unsupervised learning methods, which are the best models or best methods is there, that won't help to get the better results. The reason is your features are not good. Okay, so that's why I said that your accuracy is depending on the 60 to 7% is based on the what type of the properties or features are using. Your features are good, then you can get the better classification accuracy. Your features are not good, even though you are using the best classification methods or best clustering methods, it won't help to get the good results. For example, we can see here I have the two different type of the fruits images is there. Okay, so one is the red color apple and one is the yellow color banana. This apple, banana. So this is red color, it is yellow color. So my question is here, how can I discriminate these two fruits images? Any answer? How can I discriminate these two fruits images? One is the red color apple, another is the yellow color banana is there. First, based on the color, can I discriminate? We can easily discriminate, because I already said apple is the red color and banana is yellow color. Based on the color, we can easily discriminate. And next, second thing, based on the shape. So based on the shape also, we can easily discriminate these two images. One is the red color apple and one is the apple is consists of a round shape and banana is consists of a some kind of the tall. Okay, and what about, and the third one, based on the, for example, I am consider the taste. So I am based on the taste, I want to discriminate, but here the taste I consider the only three different type of the taste. One is the sweet taste, sour taste, and bitter taste. Now come to the each and every here what I selected the attributes like color, shape, and taste. So that we can call as a what? These all are called as a attributes or properties or features. So this color, shape, taste we can call as attributes, properties, or features. Now suppose if I use the color attribute, can I discriminate these two objects? Yes, easily you can discriminate, because apple is red and banana is yellow. And what about shape? Yes, you can easily discriminate. Apple is the round shape kind of thing and banana is the some kind of tall shape kind of thing. And taste, if you came to the taste as a one of the my attribute or property, so what is the taste of the apple? It is sweet only. And what about banana? Banana also same, sweet taste. So when you choosing the one attribute, the attribute name is the called as a taste. Okay, then both the cases means both the objects, apple or banana, both are pointing to the same value. So it is very difficult to discriminate these two objects based on the attribute called the taste. So that's what I am saying. This is the not the important attribute. So like this kind of attributes you are choosing, it won't help to discriminate your data. You need to choose the which are the attributes give the more unique information within the class or more discrimination information among the classes. So that type of the attributes and properties only you can choose it. Okay, so suppose instead of the taste I am choosing another property that is called the diameter of the your fruit. Okay, so here I said already color, shape, diameter is what? These are the attributes or properties or features. So each and every attribute contains the some value. Each and every attribute contains the some value. So that all the attributes which are you are using in your application, that all the attributes values keep it in the one place to form the vector. That vector we can call as a feature vector. Okay, you collect all the attribute values and keep it in one place to form the vector. That vector we can call as the feature vector. So for example, here I am already giving the my each attribute values. Suppose if the your color of the fruit is red color is there, then value is 2, and your fruit of the color is yellow is there, then value is 10. So these already each and every attribute contains some values, so that values I am giving. And next is shape. So in case of shape, the value ranges from, you can assume it 1 to 10 is there. So which is the more height is there, it's contain the more value. Which is the less height is there, you can assume it is a less value. For example, apple is the less height, then you can assume the value is 5, and banana is more, maybe you can assume it the 9. And next to taste, next one is the diameter. So diameter value ranges from 1 to 5. Okay, so which is the more diameter is there, it's contain the more value. So apple is more diameter, it's contain more value. Banana is less diameter, maybe it is a 2 or 3 kind of thing. So like this, each and every attribute contain the some values. Then I want to form the feature vector. So normally in my database, total how many samples is there, like apple, banana, oranges kind of thing. So total number of samples are, for example, 5,000 samples is there. Okay, so total my database consists of 5,000 samples. So I want to form the feature vector for my total database. For example, I am forming the feature vector for the sample by sample. So first sample is, I am considering here the first sample is apple related. So what are the, I want to form the feature vector for the apple. So what are the properties I am using here? Color, shape, diameter. Okay, so what is the color of the apple? It is the red color. So red color means what is the value is contained, the value is 2. So value is 2. And what about shape of the my apple? Shape of the apple is, the value is 5. So value is 5. And what about diameter of the apple? The diameter of the apple also, the value is 5. So here I am considering the 3 attributes that are color, shape, diameter, and each contain the value. The values keep it in one place. I form the vector. So this vector we can call as the feature vector of that sample. This vector is called the feature vector of that sample. So what is the dimensionality of this feature vector is? So how many attributes you are choosing? So total number of attributes 3 I am choosing. The dimensionality is the 3 cross 1 or 1 cross 3. Either you can take row wise or column wise, row vector or column wise, depending on, you can give your dimensionality 3 cross 1 or 1 cross 3. Suppose next second attribute is there, or second object is second object or second sample is there. So that is banana related. So I want to form the feature vector for my banana sample. So when you want to form the feature vector for the banana sample, here you need to remember it 2 points. So first point is, what type of the attributes you are extracted for the first sample, the same attributes you can extract for the entire database. The same attributes you can extract for the entire database. So what type of the attributes you are extracting? Color, shape, diameter. So same color, shape, diameter kind of the attributes or properties you can extract for the entire database. And second point, and not only same attributes, same sequence also you can follow. Same sequence means first color, shape, diameter is there. No, first diameter, next color, next shape, means that is a wrong way. You need to follow same sequence. What type of the sequence is followed in the first case, the same kind of the sequence you can use here also. Okay, so same color, shape, diameter. So what is the color of the banana? Color of the banana is yellow color, that value is 10. Then take that. What is the shape of the banana? Shape of the banana is, the value is 3. And what is the diameter of the, diameter is 3. And what is the shape of the banana? The shape of the banana is 9. And diameter is 3. So like this you form the feature vector for my second sample. So like this database, total how many samples is there? 5,000 samples is there. Then like this you can extract the properties or feature for the each and every sample of total of 5,000 samples. Then what is the total size of your features data? My total size of the features data is 3 cross 5,000 or 5,000 cross 3, either row wise or column wise you can consider. So like this you can form the feature vectors for your data. Okay, so that's why I said feature vectors are give the more unique information like that, such way that we can extract the properties. For example, I am taking the one test sample. My test sample are like this. So it's content my test sample is 10, 8, 2. Can you tell me this is a test sample I given? It is the apple related or banana related? It belongs to which class? Apple or banana? Then what you need to do? You can compare this one with already separated apple one, already separated banana one. So which is the closest one is there? You can identify. Based on that, you can take the decision. Okay, which is the closest one? So when you compare this test sample with the A and test sample with the B, so which is the more closest one? You can identify. B is the more closest one. Means banana is the more closest one. Then conclude banana is the this test sample is belongs to which class? Banana class. So like that, you can do the here classification kind of thing. So that's the reason you can comparing when you're doing, you need to take the same number of attributes and same sequence also you need to follow. Otherwise, it won't give the results. Okay. So that is the reason I am saying that one important feature of the one important thing in the machine learning is the feature representation. So your features are good, then only it is give the better results. Otherwise, it not give the better results. Okay. So in this, I said already, unsupervised supervised learning methods is there. So unsupervised means it is the unlabeled data kind of thing, and supervised means it is contain the labeled data kind of thing. Okay. So here many techniques or many methods is there. So I already said what is the difference means label unlabeled kind of thing is there, but what is going on internally? Okay, so what are the stages is there, what is going on internally, I want to discuss here. So for that case, I choose the two cases, case 1 and case 2. So case 1, first here one box is there. Okay, so that we can call as the data. So here what type of the data is there? You can see clearly different type of the fruits related fruits related images or fruits are available, you can assume it. So what type of the fruits is there? Only 3 different type of the fruits is there, you can assume it: apple, banana, oranges, and ignore about remaining fruits. So what are the grapes? You can what are the grapes is there? You can ignore it, and pears ignore it, and green apple you can ignore it. Only you can assume it: red color apple, banana, oranges is there. Okay. So normally, usually we are going for market to purchase the items. Okay. So grocery items or vegetables we are purchasing. So you can purchase different type of the vegetables like onions, tomato, and carrot. Like this you are purchasing. So that all are keep into the one bag. Then after came to the your home, then what will do? Just you can throw into the floor and you can separate all the carrots and keep it in one place, and all the tomatoes we can collect it and keep it in one place, and all the onions collecting and keep it in one place. So that type of the separation I required for the this data. For that separation, I'm selected one person. So the person, you can assume it, he came from the different planet. Why I'm saying he came from the different planet? Actually, he don't know about these items. What are these items? These are the eatable items or not? Or this what is this item names also he actually don't know. Okay. Then based on the some kind of information he will separate it. So how he separated? For example, here first he selected the one fruit. He selected banana from this box and keep it in separate. Okay. So next time what will happen? Next time we selected another fruit. For example, next time we selected the apple, compare with the already separated banana one. And when it's compared it's selecting up whether it is reached the up to mark or not. Suppose if it reach the up to mark, it is fine. If not reach up to the mark, then what he will do, he will keep separate. So now when you compare the apple with the banana, it is matching a little bit, but it's not up to the mark. Means it's not satisfying the threshold kind of thing. Then you will keep it here. Then given the name. So next time you selected one more fruit that is banana related and compare with the already separated banana one, already separated apple one. So which is the closest one is identified. So definitely banana is the closest one. So when you compare that one, then you keep it in near to banana. So next time you select one more fruit, maybe selected the apple, red color apple, and compare with the already separated banana group and separated apple group. And when he's compared, you check it is reached up to the mark or not, means it's satisfying the threshold or not. Suppose it's satisfying the threshold, then what he will do? He will keep it in apple group. So next time we selected the orange and compare with the already separated banana group and separated apple group. So both are not matched up to the mark, means it's not satisfying the threshold. Then what he will do? He will keep another place. So like this always. So like that, he is selecting one by one fruit from the this apple and banana oranges. So when you compare with the already separated group, which is matching with that one and satisfying the threshold, then keep it in that place. Otherwise, he will keep it in another group kind of thing. So like that, all the objects are completed from that box. Then like this kind of the group is formed. So first group is this one. So the group name we can call as a C1. Another group is this one. This group name is called as C2. This another group, this one, the group name is called as a C3. So like this, we form the three groups in case of the data one and case one. Now come to the second case. In second case here, same here the data is there. Okay. So along with the data means here also you can assume it three different type of the fruits is there: apple, banana, oranges. So oranges is there, apples is there, and ignore the pears kind of thing. And instead of the kiwi fruit, you can assume it these are the bananas. Okay, you can assume it these are the bananas. So in this case, along with the fruits, I'm giving the fruit name also, like these are the oranges. Okay, like this, along with the fruits, I'm giving the fruit names also. So here oranges and apples, banana. So like that, fruit and fruit names also given. Okay. So now I given this fruit case one means box one data one to the this person. So you will see the fruit names and fruits also. Then his tuning is brain, his update is brain. So how he can update his frame? In this example, he will update his brain in terms of the rules kind of thing. How some red color, some size, some shape is there, people call as apple. Some yellow color, some size, some shape is there, then called as a banana. And some kind of orange color, okay, some size, some shape is there, then people call as oranges. So like that, he's tuning his brain, is updating his brain. Okay, so that is happening in the data one. Next, another box is there, that is the data two box. In this box also you can assume it three different type of the fruits, bunch of fruits is there, apple, banana, oranges, and remaining fruits you can ignore it, like grapes or in pears or green apple kind of thing, ignore it. It is not there in the box. Some bunch of fruits is there. Okay. Now here thing is, based on the data one, I need to separate the data to box. Based on the data one, I need to separate the data to box. How can I separate this data to box given to that person? Then he need to separate. So the person already tuned his brain. How he tuned? Based on the data one, he found the same set of rules in his brain. So based on that, he can easily separate the data to. How can separate? He already knows some kind of yellow color, some size, some shape is there. People call as a banana. This is also called as a banana. This is called as a banana. This is called as an apple. This is called as an apple. This one is apple. So this is orange. This is orange. This is apple. So like that, he will generate the labels for the data too. Okay. So like this, he will separate or he will generate the labels to the data too. So that is happened in the case one. Now come to the again the first case. So here data is there. Okay, data is nothing but here data is there. How the my data look like in the case one? We have the data that is unlabeled data. Unlabeled means only I give you the fruits, I am not giving the fruit names. Only I given the fruits, I am not given the fruit names. So that's the reason I am called as a here. That is the unlabeled data. Data plus unlabels. Okay, unlabeled data. So when the unlabeled data is there, means there is no labels, then you can go for the unsupervised learning methods. So unsupervised learning methods. So unsupervised learning methods, they will call as the clustering problem. Unsupervised learning methods, they will call as the clustering problem. So clustering is nothing but what? Is the clustering is nothing but is the process of grouping the data objects. Is nothing but processing the group of data objects. How the group the data objects? which are the objects have the similar properties is there, you make them as a group. Okay, so which are the objects have the similar properties is there, you can make them as a group. So you can see, for example, here the C1 is contain the what type of the objects, all are banana related objects. C2 contain the what type of the object, apple related objects, and C3 contain what type of the objects that are orange related. So in that group, all are have the similar properties or different properties. So all are have the similar properties is there. So like that you are forming the clusters, and you can have the clusters have the cluster name is the C1, C2, C3. So that is happened in the case 1. Now come to the second case. Second case, you have the data 1 is there. So that data 1 is we can call as the training data. Data 2 we can call as a test data. So basically when you are going for the supervised learning algorithms, okay, so here the train data is there. In the case 2, how the train data is contained, it's contain the labels. So along with the data, I give the labels also. Along with the data, I given the labels. So along with the labels means what I given here, fruits and fruit names. Fruit name is nothing but the label, fruit is the data. So that we can have called the training data plus labels we are giving. So this, when the label data is there, then we can go with the supervised learning algorithms. The supervised learning algorithms we can call as a classification problem. Okay, so where the when the data is there, okay, so the data is the contain the labels that we can go with this, we can call as a supervised learning algorithm. Supervised learning algorithm called as a classification problem. So in this supervised learning algorithm, basically two type of the data sets is there. One is called the train data, another one is called the test data. So basically supervised data set consists of a two type of data sets. One is the training data, another one is the test data. So here data 1 is what? This is the training data. Okay, data 1 is the training data. So normally the training data given to the your classification algorithm, then that classification algorithm will be generate the output as a model. So here this train data given to the person. Person is nothing but your classification algorithm. Okay, then what he is doing is tuning his brain and providing some output. So that output we can call as a model. It's not output, it's tuning the brain. Tuning the brain means it will generate the model. He is tuning the brain means it generate the model. The algorithm, you can give the algorithm to data means algorithm will be generate the output as a model. Model is nothing but what? Model is nothing but is a set of rules or set of parameters. So depending on the your what type of the algorithm you are using, some of the algorithm will be generate the set of rules kind of thing, that is a rule based methods kind of thing, and some algorithms will be generate the parameters. So in this case, in this example, it will be generated the rules kind of thing. What type of rules? For example, your sample means your fruit contain the red color, some size, some shape is there, then they will call as an apple. So like that is tuning his brain and form the some set of rules kind of thing. These rules we can call as a model here. Okay, so next, what is the data 2? Data 2 I call as a test data. Okay, so along with the training data, once training is completed, next give the test data to that person. Then the person already knows, okay, based on the rules, he will generate the labels for the given the test sample. Given the test sample that is going on normally regularly. So based on the training, he will have a subset of model or rules. Based on that, next what you are giving the test sample. Then for test sample, he doing classification means what? He generated the labels for the test data. On which basis he generated the labels? Based on the training model. Okay. So other than training and testing, one more data set is there, that is called the validation data set. Other than training and testing, one more data set is there, that is called the validation data set. So what is mean by validation data set? So validation data set is not the separate data set. It is not the separate data set. It is just a part of the training samples only. Part of the training samples means, for example, in training sample, 100 training data consists of 100 samples. Out of this, either 10% or 20% samples you can use as a validation. So 10%, 20% sample you can use as a validation. So what is the purpose of the validation data is? is need to get the better model as a output at the time of the training. At the time of the training, we want to get the better model as the output. This validation data will be helpful. How it is helpful? For example, you are preparing for the exams. We have the machine learning exam is there, and today you are preparing until today night. Okay, so maybe before sleeping or maybe after the wake up early morning. Normally, usually everyone what will do, you can question by yourself, like what is the machine learning, what is the feature representation, what is the supervised learning algorithm, like that question by yourself. So when you are questioned by yourself, then you try to give the answer. Okay, so what is the machine learning? Machine learning is one of the application of the AI, like that you are trying to give the answer. Suppose you are unable to give the answer, then what will do? Again, you can go to the room and open the textbook, again read, and again come back, again question by yourself. So anyway, after 3-4 hours is over, then you are going for writing the exam. Then why you are questioning by yourself? Why you are testing by yourself? So that time when you are testing by yourself, you are trying to give the answer. If you give the correct answer, then definitely sure you will write it in the exam. The same way here, validation data also, at the time of the training, this validation data they use as the test data. At the time of the training, what you are choosing the validation like 10% or 20%. So that is act like a test samples. So that test by with that model itself, then it is correctly giving okay. If not giving, again tune the parameters, again reform the rules kind of thing. So like that, if you are doing like such way that, then you will get the better model as output. For example, at the time of the training, so he is questioned by himself. So what type of the question is given? Some red color, some size, some shape is there. Then he think it is a banana. Then he will go and check the banana. No, it's the red color, some shape, some size is there. Then people will call as a, it's not banana, it's apple. Then he tune it again the bread. So like that in the at the time of the validation, so that will be help to get the better model as the output. Okay, so like that we can choose the validation data. Okay, now here what are doing, you are how the training data is there. Next we are extracting the features properties, that is called the feature representation. Then these features are given to the some classification method. For example, here I'm using one support vector machine classifier is the one of the classification method. So the method what will do, the if you give it to person is nothing but the algorithm, that is person is nothing but algorithm or classification method, you can assume it. Then the person what is generating output, the generating output is nothing but the model is nothing but a set of rules or set of parameters. And next is the same test data given after test data you are extracting the features. So data 2 is called the test data, and these features are given to the model. Then model what will do, it will be generate the labels for the given test samples. Okay, now you can give that this training data means data 1 to the person. Then person after training is completed, next when you are giving the test sample to the same person, then what he did, he generated the labels for the data. So data 2 labels are generated. So like that he is how the classifying the test data samples. Test data samples here is nothing but the data 2 samples. Okay, so this is normally in the supervised unsupervised is going on. So what are the actual stages is there, I will show here. For example, you have the training data is there. In case of supervised learning algorithm you are showing, because some of the stages in both supervised and unsupervised is both are same. Next, you have the train data, so that to label data because it is supervised right side. Next, what you are doing, you extract the properties, that is called the feature representation. So what type of the features you need to extract? Just before starting of this session, I already explained, depending on the data, that related properties only we can extract. For example, your data is a documents related, means text document related. So text document related properties you need to extract, like keywords, special words kind of thing. Suppose your data is related to the particularly signal related, the signal related properties you need to extract, like MFCC features kind of feature representation you can extract. Suppose your input data like humans related, then human related properties you need to extract, like height, personality, gesture, walking style, skin color, like this kind of information we can extract. Okay, then after extracting the properties, before going to the next stage, here I want to say one more intermediate stage is there between the feature extraction and input data, that is called the pre-processing stage. Okay, so what is mean by pre-processing? Pre-processing is nothing but before actual task. Before actual task, you want to perform some operations on your data. That operations we can call as the pre-processing method. Before actual task, you want to perform on some operations on your data. That operations we can call as that operations or methods we can call as the pre-processing methods. For example, here we have the some ultrasound images kind of data is there. Okay, in medical data some ultrasound image data is there. So normally you can see ultrasound images, it consists of a lot of noise information. So what type of the noise information is there? Some data noise information is there, like this kind of data noise information is there. Okay, so some noise is there. So here in this ultrasound medical image data, you need to identify whether the person have the any tumor or cancer or not. So where is he have the tumor or cancer, you need to identify. So because of this noise information, sometimes very difficult to recognize whether the person have the tumor or cancer. So in that case, what you need to do? First, you can remove the noise. For example, remove the noise. You have already have the denoising methods are available. So you can apply the denoising technique on this. Then you can easily remove the noise information. So once this noise is removed, then you can apply the some XYZ method to detect the whether the person have the tumor or not. So what is my actual task? My actual task is I need to detect that person has the tumor or not. If the tumor is there, in which position he has the tumor. But what I am doing initially, instead of the detection, I am applying some technique, the denoising technique, and to remove the noise information. So the denoising technique, what you are using that method, that we can call as a pre-processing method. Okay, so the pre-processing methods are not compulsory. I said that is the optional. Depending on your data requirement, you need to apply the what type of the pre-processing technique you need to apply. So pre-processing techniques or methods also not fixed. You can use any method as a pre-processing method. So that is maybe simple method or maybe any method. Either you can use supervised learning algorithms or unsupervised learning methods. Any method you can use as a pre-processing method. For example, another case I'm showing here. So I'm collecting the some images. My own image data is collecting. Image is nothing but what? Two-dimensional data. Okay. So I collected my own images from the camera or something. For example, some of the image size is 10 cross 10 is there, and some of the image size is 11 cross 11 is there, and some of the image size is 12 cross 12 is there. So like this, different size of the images are available in entire database. So total how many samples is there in the database is 5,000 to 6,000 samples is there. Okay, so here I want to extract the feature vectors for these samples. So for example, here it is the two-dimensional data. You can assume it this is as a matrix kind of thing. So 10 cross 10 matrix means how many values is there? In 10 cross 10 matrix, 100 values is there. So that 100 values I can use as my feature vector. So what is the size? 100 cross 1. So here 11 cross 11, how many values is there? 121 values is there. So if I use this 121 values as my feature values, and another type of the size, what is there? 12 cross 12. So 12 cross 12 contains how many values? 144 values. So like this, in the database, different sizes of the images are available. So each image you are extracting the properties depending on the size. So first images, some of the images 10 cross 10 is there, that feature vector size is 100 cross 1 you are getting. Some of the images are contain the size of 11 cross 11 is there, it contain the size of the feature vector is 121 cross 1, and some of the images contain the size of the 12 cross 12 is there, then you can get the feature vector size of the 144 cross 1. Like this, in my database, total how many samples is there? 5,000 samples is there. So then each feature vector collected and keep it into the matrix form. First one, second one, third one, fourth one, like that. I different total 5,000 samples is there. Then I need to keep the all the 5,000 samples to the in this combine the one by one. I need to form the complete matrix. It is possible the different sizes of the vectors you can keep it in one matrix. It is possible. It's not possible because one is 100 cross 1, 121, 144, or 144, or 100, or 100, like that. Different sizes is there. So different sizes is not fit into the matrix. Then what I need to do? All the images are being into the equal size. So maybe all the images are being bring into the 10 cross 10. then all are vector contain the 100 cross 1, 100 cross 1. Then total, what is the size of the my total database is 100 cross 5000. So like that, I will form the feature vector of the my data. So here, what I did, the images is there of different size, but what I applied, resizing the images. So when resizing the images, okay, so I resize the images. When resizing the images, then I will apply the actual task is I want to do the classification, but I apply the technique is called the resizing images. That is also one type of the feature pre-processing method. Okay, so here the simple pre-processing method, you are resizing the images. So I said the pre-processing method is not the fixed kind of thing. Any method you can use as a pre-processing method, either bigger method or smaller method or any method. Even you can use the clustering methods or you can use the classification methods. Any method you can use as a pre-processing method. Next, after that you are extracting the properties, you need to select the any classification method. Suppose I am selecting the my classification method is the support vector machine classifier. So you are extracting data given to the support vector machine classifier. So the data given to the here in this case person is the my classification algorithm. Okay. So before giving to the person, here also one intermediate stage is there. The intermediate stage we can call as the dimensionality reduction. So the intermediate stage is called the dimensionality reduction. So dimensionality reduction also it is optional. It is not compulsory. Okay, so depending on your data requirement, you want to go for the dimensional reduction or not. So basically, why you are going for the dimensional reduction? Obviously, you are doing the dimensional reduction means size will be reduced, computational fastness will be increased. But why we are going for dimensional reduction is to eliminate the where the redundant information is there, where the irrelevant information is there. To avoid that one, we can go for the dimensionality reduction method. So maybe two different type of the dimensional reduction methods are available. One is the feature selection and feature extraction. So that already before this session, you see the one of the dimensional reduction method is called the PCA, principal component analysis. Okay, so that is one of the unsupervised linear dimensionality reduction method. Okay, so that we already seen. I am not explaining that one. So like that, you extract the reduce the dimensionality. Once the dimensionality reduced, that is also I said optional. It is not compulsory. Then you can choose the classification method. So you are choosing the classification method that is called the support vector machine. For example, it is unsupervised learning method case up to dimensional reduction same stages is there. So instead of the classification method, you need to select the clustering method. Instead of the classification method, you need to select the clustering method. So now if you choose the support vector machine classifier, then what will happen? It will produce the output is nothing but that is called the model. So in that person case, you can given that this sample feature extraction sample to the person is the classification method. So the person what is generating model as output. So that is the model is generated. Means the features which are the dimensional reduction features given to the classification algorithms, the algorithm will be generated, means algorithm will be tuned, and after that it will generate the output. That output is called the model. Model is nothing but I said already is the set of rules or set of parameters. The same way here we have the test data is there. Okay, so what are the test data also it is contain the labels because it is supervised learning algorithm. And next here also same type of the features. So what type of the features is there for the training samples? Same type of the features you can extract for the test samples. Okay, same type of the features you can extract for the test sample. For example, trained sample you extracted some, you can apply it on the some kind of the pre-processing method or technique. The same type of the pre-processing technique you can apply for the test samples. Okay, so if you not applied any pre-processing kind of techniques, no need to apply any pre-processing methods. Okay, next, suppose you apply the any dimension reduction method on the training samples on training data, same dimension reduction method at same dimensionality you need to reduce it on test samples. If you not apply any dimension reduction method on the training samples, there is no need to apply the any dimension reduction method on test samples. Next, you can give the this features to the model. Then model what will do for given a test samples, it will be generate the labels for given a test samples. So that labels we can call as the predicted labels. The labels we can call as a predicted labels. So this is the label generated, model is generated output labels. Okay. Now how can you quantify your results? Whether your generated labels are correct or not, how you know? In that case, you can compare the your actual labels with the predicted labels. Okay. So already it is the supervised learning algorithm. So already test data also how the labels is there. So that labels you can compare with this predicted labels. Based on that, you can calculate some kind of performance metrics that is called the accuracy or error kind of thing. Accuracy or error based on this predicted labels. So like that, you have the stages in the classification and clustering. Okay. Now, what is going on internally when you are doing the classification and clustering? So for example, how the data is like this is there in unsupervised case. So this is my data. So here dots are data means it is unlabeled. So that's the reason I am showing with the dots. Okay. So for example, you have play the clustering technique on this data. Then what will happen? It will form the 3 clusters. This is one cluster. This is another cluster. This is another cluster. So each cluster have the name. The cluster name is C1. This cluster name is C2. This cluster name is C3. Okay. So you are forming the clusters means what? You are grouping the clusters. How you are grouping the clusters? So which are the objects are belongs to cluster, that all objects have the similar properties. So you are doing clustering means what is going on internally. So it will be generate the labels for the data. You are doing clustering means what? It will be generate the labels for the data. How it is generating the labels? So which are the objects are belongs to the cluster, that all the objects share the cluster name as the object name. So which are the objects that belongs to the cluster, that all the objects share the cluster name as the object name. So this object is, what is the label of this object? This object belongs to which cluster? C1 cluster. Then it's labeled as a C1. Then what about this one? This object belongs to which cluster? C1 cluster. This is labeled as a C1. So this is C1. This is C1. And what about this? C2. This is C2. This is C2. And this one C3. This one C3. This one C3. So like this, you are generating the labels for the data. You are doing clustering means what is going on internally? You are generating the labels for the data. Okay. So here in the case I told what I told. You are selecting the each and every fruit and keeping separate kind of thing. See, normally for your understanding purpose, I told okay, you are moving like that, but data will not move. Data is in the same place. Based on that only we can form the clusters. Data is not move. Data is in the same place only. Okay. So based on the similarity, we can form the cluster means form the group kind of thing. So you are doing clustering means you can remember it. You are generating the labels for the data. Okay. So that is going on internally. Now come to the classification. So in the classification also, 2 classes data is there. You can assume it. For example, plus class minus class is there. Okay. So if you want to discriminate, these samples we can call as a training samples. So with the help of the training samples, you can use some kind of classification method. For example, you can use a support vector machine classification method. So it will be training, and finally after training completed, what it will be produced? It will produce the model as a output. So the model is nothing but this line. So this line we can call as a hyperplane, decision boundary, or model. Yeah, the training data is there. The training data given to the one of the classification method, any classification method like support vector machine or neural network or whatever it may be. So after training is completed, then what will be produced? It will produce the model as output. So that is nothing but the hyperplane or decision boundary or model. So what it will be tell, based on this decision boundary or hyperplane, it will tell to the input if any sample above this line is there, then you can consider as the positive class. If any sample below the line is there, then you can consider as the negative class. For example, in this case, what I'm doing, I'm selecting the one test sample. Okay, so my test sample is here. This circle point is the test sample. Now, can you tell me this test sample belongs to the which class? Positive class or negative class? So actually, where is the test sample? The test sample is above the line. So above the line, then I conclude this is called as a positive class. How you concluded? Based on the hyperplane or decision boundary or model. So already your hyperplane is saying If any point above the line is there, then you can consider that is as a positive class. Okay. Now, if I have the one test sample is there here. So in this case, what is the class of this test sample? It is the native class, because the reason is it is below the hyperplane. So below the hyperplane is there, then all the samples we can consider as the native class. So like that we are doing the classification. Okay. So what is this equation? Y equal to mx plus b. Okay. So y is the your output and x is the input and c is the intercept point and m is the slope kind of thing. Suppose if I not selected c, then what will happen? Not selected c, then what will happen? Y equal to mx. If you not selected c, then what will happen? The line always pass through the origin. So if line is always pass through the origin means our data in the sample space anywhere. Maybe our data is like this is there. Here plus class and here minus class is there. Now here this is the you can consider as the your hyperplane. It correctly classify your data. No. Maybe my data is like this is there. Here plus class and here minus class is there. And in this case, it is this hyperplane is correctly classified. No. In both the cases, not correctly classify the data. Means our hyperplane is anywhere. For example, in the below parts case, this is maybe hyperplane, and here maybe this is my hyperplane. Okay. So that's the reason y equal to mx plus c. Now, if you have a little bit idea about the classification methods or techniques, so they will say at the time of the training the model, with the help of the training the data, so it will generate the function. The function is nothing but the discrimination function. So that is g of x equal to w transpose x plus b. So this will be generated at the time of the training. Means your training is doing with the some kind of classification method. So that will be produced that this is the output. So this is nothing but what? Both are same or different. Y equal to mx plus c, g of x equal to double transpose x plus b. Both are same. Here also x is the input and g of x is the output and b is the intercept point or bias and w is the slope or weight matrix. Okay. So at the time of the training, it will generate this one means what? It's generating the hyperplane. Okay. It's generating the hyperplane. So that is we can call as a model. Model is nothing but not any physical attribute or physical entity kind of thing. So it is consists of a set of rules or set of parameters, I said. So what are the parameters here? It will store weights and bias related kind of thing. So that example case, it is the consists of a set of rules, but here it's consists of a set of parameters. Okay, so you are doing the clustering means it is you are generating the labels for the data. How you are generating the labels? Which are the objects or belongs to the cluster, that all the objects share the cluster name as the object name. So like that you are generating the labels for the data in case of the clustering. And what is going on? You are doing the classification means in the classification means at the time of the training it will generate the model. So you are constructing the model. Okay, so model is nothing but the set of rules or set of parameters. So based on that model, you can decide whether it belongs to what class, either positive class or negative class. Okay. So like this, we have the what is going on internally, supervised and unsupervised learning methods. Okay. So many techniques are available in the machine learning. So some of that methods or techniques we can cover in this FDP program. Already some of them already covered, like decision trees already covered, and dimension reduction method also you can cover, and maybe coming sessions one of the regression models also cover. Coming sessions we can cover with another kind of techniques also, like neural networks or some regularization kind of techniques, or maybe Bayesian kind of learning methods. So all these methods are in this classification or clustering kind of techniques or methods are there. Okay. So now why we are going for the machine learning techniques? Why you are using machine learning techniques? So if I ask this question, so most of the people will say we are going for the prediction or analysis kind of thing, or we are going for the automation kind of thing. So these are the regular kind of things. Actually, why you are going for the machine learning techniques? What is the reason? So, for example, you can see, especially in India, last 4 years or 5 years onwards, or maybe 5 6 years onwards, lot of internet usage is going on. Okay, so previously, if you want before 6 7 years back, if you want to use the internet, means maybe you can take the special package kind of thing or buy it other than phone calls and you can use it. But nowadays, this internet is coming with your phone call charges only. So everyone have the smartphone or mobile phone is there. Then everyone have the this internet facility is there. Then everyone using from the last 5 years onwards. Most of people, from the small kid to the until some aged person. Okay, so who are using this kind of internet facility, small kid, maybe I seen many persons even 5 years onwards are not five, maybe 8 years onwards are they using the internet kind of thing. And some aged person, old persons also like 60 70 also they using 8 70 also. From the morning wake up time to until sleeping time, many apps are they using, these people. So what type of the apps they are using, like Google, Facebook, WhatsApp, and some other kind of apps also they are using. They're using these apps means what is going on in the real time. So suppose when I am organizing the workshops in NIT Warangal, so many participants came from the entire India, from different places. They, some of them they will come with the friends, and when the sessions is going on, once the session is completed or break time, maybe completed means after 5 o'clock here regular offline kind of sessions is completed, or maybe somewhere in the middle also intermediate also some other breaks is there. So in that case, so most of the participants what they will do, they will roaming the campus and they will take the photos. Then after taking the photos, what they will do, they will immediately they will share to their friends and their relatives through the using any one of these following apps like Facebook or maybe WhatsApp or any kind of apps they will use. So like this going on, then what is going on? Lot of data generation is going on, lot of data transformation is going on. Okay, so day by day, lot of data generation is going on, lot of data transformation is going on. So to efficiently retrieve the data more effective way, then these machine learning techniques are helpful. So that will be really more useful to the currently which other people are using. That will be really helpful using this machine learning techniques. How it is helpful? For example, here one how the one room is there. Okay, so in this room, some thousands of millions of images is there. How many images is there? Thousands of millions of images is there. So basically, what type of the images is there? Like real-time images. Real-time images means like car-related images, bike-related images, flower-related images, and computer-related images, rail-related. Like this, 10 different category of many bunch of images are available for each and every category. Okay, suppose I given the one task to you. The task is I given the one image to you. That image is flower related image. Then I'm asking to go and inside this room, bring the similar type of the images which are available to the flower. You can bring all the images. Then you have started your task. You are entered into the room. Then you are searching one by one image. So how many days it will took to complete your task? How many days it will take the time to you can complete the task? So in this, how many images is there? Thousands of millions of images is there. So you are searching one by one. Then what will happen after the few days is over? Your performance will be decreased. Okay, and accuracy also decrease. Here performance is decreased, accuracy also decrease. Okay, suppose instead of that one, I did the some modification. So what type of the modification did? I arrange the some kind of the rooms. Okay, so like this I arrange the some kind of the almara, some kind of the book shelf kind of thing I arranged. So each almara or each birwa dedicated to the one category. So first one is the flower related images will be stored into this almara or this birwa, and next computer related, and next is car related, next bike related, like that each and every one category assigned to the one almara. Next, I given the same task. Then what you'll do? Again, you enter into the room. Again, search one by one. So when you search in the one by one, what will happen? So automatically you can find out the which are the similar type of the images is there. Okay, then you can go and see here. Only first one is the flower related image and remaining all are not flower related images. Then no need to search. I'm right. So just you can first one is chosen. So based on that, you can easily go and find out the open that first birva or armala. Then you can search the which are the flower related images. You can easily retrieve it. So in that case, what will happen? Your performance will be increased, accuracy also increase, because no need to search remaining all almara kind of thing. So what is the difference compared to the previous one and first one and current one? The difference is previously I am not arranged the my data. Just in the room, some bunch of millions, thousands of millions of images is there. Okay, then you can go and you can search it. Okay. Now second time what I did, just I arranged this images into the some particular category wise or some particular criteria kind of thing. I use the almaras to the arrange it. Then after that I given the same task. Then second time when I given the task, then you can easily implement it and you can get the better results. So the main difference is second time organized data. So because of organization, definitely you can get the better results. So the same way nowadays, many of the which are the apps or which are the websites or which are the things is there like Google or Facebook or anything. So lot of data transformation is going on day by day. So here I am taking the numbers mostly like 4 years back kind of the numbers, but this 4 years onwards lot of changes came, lot of usages, internet usage is there, and these numbers will be vary mostly. For example, here Google is there. Google process 24 petabytes of the data per day. It's not 24, maybe 50 petabytes of the day. And Facebook not 10 million, maybe 40 million photos are uploading every hour. Like YouTube, 1 hour video is uploading every second, not 1 hour video. It's maybe 4 or 5 hours video uploading every second. So like this, different apps, so they have a lot of data transformation is going on. So they're using currently, they use this machine learning or whatever it may deep learning techniques to organize the data. So that's the reason we are getting the effective results kind of thing. Okay. So like this, lot of improvements came in the day by day kind of thing. Now here you can observe it day by day, lot of improvements is coming the technology. So we can see day by day, we can never thought if you go 5 years back, you can go. Previously, we not thought like customer care kind of services is there. Then after that, chatbots came. Then after that, chat GPT came. So we never expected like that. A lot of improvements is coming from the technology side. Day by day, lot of improvements is coming. But what is going on? That improvements coming fine, but what is going on? The technology makes the humans to the lazy, but humans make the lazy kind of thing. So how it is makes the humans to the lazy? You can generally can assume it your lifestyle kind of thing. For example, maybe I remember if we are go 25 years or 20 years back, we not have that much of mobile phone usage kind of thing. So in those days, suppose I remember each and every person we have the landline phone numbers kind of is there. So each and every person remember the minimum 10 landline numbers, including the district code of their friends or relatives phone numbers. Nowadays, if you ask the any person, it's not only outside, just you can ask you who are the home related, like your brothers or sisters or any other kind of closely one. We are unable to remember the phone number. If you ask the any person phone number, immediately you can open the mobile contacts and then you can open and see and we are telling. We are not remembering that kind of information. Not only that, I remember those days when you want to do the any calculation kind of thing, like multiplication kind of thing, 2 digits at 3 digits numbers kind of thing also, we can do in our brain and we can give the quick answer kind of thing. Like that kind of complex multiplications also we can do by our own self in the brain itself. Nowadays, if you ask the simple question, like it is whether the 2 digit multiplication or single digit multiplication, whatever it may be, we are first of all we are not thinking whether I will solve or not. Immediately you open your mobile calculator and typing and giving the answers. So like that, it makes the humans too lazy. Day by day, technology is improving, but the results of that one, what is happened? It makes the human to the lazy. So it makes the human to the lazy means what is going on everywhere. Everywhere humans are replaced by technology. So for example, you can see the some places like maybe you can see the one parcel center kind of the places, big parcel centers like Amazon parcel centers kind of places. So in that case, humans are not involved. Humans are not involved. So some machines is there that we can call as a one type of the robo. So that will collect the parcel and keep it in appropriate places. Okay, so because of that, what happened, because of this technology, many places are humans are replaced by technology is nothing but robots. Okay, another case you can consider, I said already a simple example. If you go 5 years back, we have the one kind of thing is there that is called the customer care support kind of thing. Suppose you purchase some kind of the items, so you are facing any kind of issues or any kind of problems, then immediately we can call to the customer care. Then they will give the some kind of inputs or solution to the person. But nowadays, what you are seeing, there is no customer care service kind of thing. They will, instead of the humans, they will keep the machines. That machines is giving the response what you are asking the question. So that machines we can call the chatbot kind of thing. So like that, a lot of changes came. So all this leads to the what is the issue is everywhere humans are replaced by the technology, because the technology day by day a lot of improvements is coming. Okay. So this is the main thing is going on the machine learning currently. And what is the difference between the traditional programming and machine learning? So traditional programming is nothing but you can assume it like C or C++ or any other programming languages. What is the difference between that programming language and machine learning? Okay. So here I need to give the clarity on that. So normally in your as a faculty in your lifetime, maybe you can teach one time any programming languages, or maybe in your college time, maybe you can study any programming languages. So normally programming language we have the labs is there. So in that lab some set of programs is there. Okay. So one of the program is like this. For given input, we need to identify it is the prime number or not. So like that, you have the lab assignment is there. So that lab assignment you can give it to the student. Okay, then what the student will do, first he can find out, he can take the some input data. So input data maybe is taken the 5. For that you need to write the logic, nothing but program. You need to write the logic. So what type of logic, whether the given input it is a prime number or not, he will write the logic or program. So for example, he written the program, both are given to the computer. So computer initially compile this what you written the program. Then if any errors is there, it will say errors, and if no have the errors, then it is correctly compiled. So once compiled completed, then it will be generate the output as a your program. So what the output will be generated for given input and program. So definitely your input is 5 is based on the, your logic is corrected, then it will generate the output is that it is a prime number kind of thing. So like this, it will generate the output. Okay, so this is normally any programming language. You can see this kind of the stages, like you have the input data is there, and you have give the build the program, and next given to the computer, then computer will generate the output. The output is nothing but prime number. Next it comes to the machine learning. So here also you are taking the input data. So what is my input data value is 5. Okay, so you collected the your input data, that is a 5. Next, what is the output of this one? What is the input to the output? Output is 5 means what? 5 means prime number. So you are taking the input data and corresponding label. Okay, input and corresponding label. So both are given to the computer. Then computer what will do? It will generate the output as a program. So this will be output. So previous case output is the, it is the label is giving. In this case, it will generate the output as a program. So in case of traditional programming language, program is the input. But in case of machine learning, program is the output. So this is the difference between the traditional programming and machine learning. Okay. So these are the, you can see here clearly. So in case of, in a traditional programming language, so you have the data is there. So data is the, your input data, like 5 kind of thing. and program is the logic, means finding the prime number logic you written. So both are given to the computer, then computer will be generate the output. Okay. In machine learning, what you are doing, you are taking the data, that is the input 5, and output is the label. So that is called the your prime number kind of thing, and here output is the program is generated. Here input is 5 and output is the prime number. So this is the difference between the traditional programming and machine learning. Okay. So in this session so far, what you learn, how the data is there. So data is contained the different forms is there. So based on the data, they are using the terminologies like different type of the terminologies they are using, signal processing, medical imaging, computer vision, like this I discussed. So I said already different formats is there. Based on that, you can extract your properties kind of thing. Okay, so data is different formats. First, we need to identify the data is the labeled data or unlabeled data. If it is labeled data, then you can go with the supervised learning algorithm. If it is unlabeled data, then you can go with the unsupervised learning methods. So in supervised learning methods also again two categories is there. Maybe your data is a continuous data or discrete data. So continuous data means, like I said already, it is a contain the output also continuous values kind of thing. It's contain the continuous values like house price prediction. House price is the continuous values kind of thing. Where forecasting, that is a continuous kind of thing. So where the continuous data is there, then you can go with the regression models. So regression models also types is there. Like linear regression, multilinear regression, like that variations is the logic. And another one is the, if that is the discrete data, like images kind of data. So in that case, in discrete data, then you can go with the classification methods. So different type of the classification methods is there. That is support vector machine classifier or neural network classifier kind of thing, or some other navigation classification or decision trees, like many classification methods is there. So when the data is the discrete data is there, then you can go with the classification method. When the data is continuous data is there, then you can go with the regression models. Suppose your data is unlabeled, then I said already you can go with the unsupervised learning methods. So unsupervised learning methods we can call as the clusters. You can use a form the clusters. So different type of the clustering techniques are available. Then you can use the all this different type of the clustering mechanism to form the clusters. So that is you're doing in the clustering mechanism. Okay. So this is you learn in this session, this one. So if you have any doubts is there, you can ask here. Any doubts, any questions? Yeah, participants, you can unmute and you can ask your doubts and your questions.
Sir, can we get the video recording of this?
No, video recording is not provided.
And PPT, sir?
PPT they will give depending on the speaker. If the speaker interested, he will provide that you can collect from your coordinators. So they will share to the coordinators some of the speakers. Then you can he will share to all the participants.
Okay. Thank you, sir.
Yeah, fair. Any doubts?
No, sir.
Yeah.
So any question from the audience? Any doubt? I think no, sir. It was very clear.
Okay. So if no doubts, then we can wind up today's session. Maybe we can continue the remaining part on supervised methods and techniques. Maybe how the tomorrow sessions is there.
Yes,
we can
sir.
continue it. We can continue it.
Yeah, we will continue at 3 p.m. from tomorrow. Yeah.
Yes.
Yeah.
So now I am closing the session.
Yeah, sure, sir.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.
So we resume tomorrow at 3 p.m.
Yeah.
Thank you, everyone.
Sir, tomorrow's class is from 3 to 5 or is it
Ma'am,
3 to 5 and 5 to
5
7?
to 7. There are two
Oh.
classes, no?
Okay.
3 to 5, then
No, sir.
5.
I thought it's a Sunday, so.
No, ma'am. Yeah, it's.
Okay.
Yes, ma'am.
Okay, thank you.